Hi Math, I'm Andy. Today let's take a look at perfect squares and square roots. I was thinking we've been working with exponents lately, and if I have the number, say 3 to the 4th power, that's literally what we say, 3 to the 4th power. But I noticed that when I talk about a smaller power, like the power of 2, we generally don't say 4 to the 2nd power. What we generally say is 4 squared. We use this kind of different term to define a power of 2. We say 4 squared. And so I want to look at the kind of origin of that topic first. Why is 4 to the 2nd power called 4 squared? Well, the reason being is because of the actual shape of a square. Now, a square is very unique in that it has 4 right angles and it has 4 equal sides. So 4 squared, we know, is a value of 16. And where that really comes from is the shape of a square that has 4 on each side. If I take a square and I cut it up into 4 equal parts one way, and I cut it up into 4 equal parts another way, if I count out how many parts there are, and you'll notice each part that I've cut this into is also a square, that it's a square of 1 by 1, there are a total of 16 parts. And 16 parts is the value of 4 times 4. So we say 4 squared, and we use the power of 2, because really we're representing the shape of a square that has a length of 4 and a width of 4. And just to show you, this actually works with all of the numbers when you square them. So again, let's just take a look at a square. And let's say this time I cut the square into 3 equal parts one way, and I cut the square into 3 equal parts the other way. So this side is 3, and this side is 3. Well, I can say this is 3 squared, and 3 squared is equal to 3 times 3, which is length times width, and 3 times 3 equals 9. And if I take all of these 1 by 1 squares inside of here and I count them up, there are 9 parts. There are 9 1 by 1 squares in that squared. So again, this power of 2 is kind of a unique exponent. We say that 3 is squared because we're literally referring to the shape of a square that has the length and width of that base value, in this case 3. Now, I want to talk about perfect squares. Now, perfect squares kind of come from that idea of a square. They're unique numbers in the integer family. So let's take a look at some squares, and I'm just going to zoom in really quick. Let's say that every 2 blocks represents 1 on this piece of paper. So the smallest square that I can make is 2 blocks by 2 blocks. And if I look at that, that's going to be my perfect square. That is a 1 by 1 square, and 1 squared is 1. So the smallest block I can make is a 1 by 1. Now I can extend that if I instead go down 4 blocks, which will count as 2, and I go over 4, what I have is another square. This square is 2 by 2, so we'll say 2 squared, and I get 4. If I extend it a little further and I go down another unit, so 1, 2, 3, and I go over 1, 2, 3, I've created another square. This is a 3 by 3 squared, and 3 by 3 is 9. And I can kind of continue this pattern. If I go down another, so I make it 4, and I go over 4, 1, 2, 3, 4, and I draw my square. This is a 4 by 4, and 4 squared is 16. So these answers, 1, 4, 9, 16, these are very, very important numbers that we call the perfect squares. And now squares can actually come in any shape and size. And so the squares, the perfect squares of mathematics, actually goes up forever. And we generally work with some of the single digit squares a lot of the time in math. And so let's kind of complete our list. We know 5 squared is 5 times 5, and 5 times 5 is 25, so 25 is a perfect square. 6 squared is 36. 7 squared is 49. 8 squared is 64. 8 times 8 is 64. 9 squared is 81. 9 times 9 is 81. And 10 squared is 100. 10 times 10 is 100. And again, we can continue this process. We can keep going. 11 squared, 121, 12 squared, and down the list. And it will eventually go on forever because squares can be as big as you want. So we have figured out what a perfect square is and how to figure it out. You take the same number, you times it by itself, and you get that square number. Now, math is always full of inverses. If you do things one way, you can always go backwards. If you add 3, you can take away 3. If you multiply by 6, you can divide by 6. So addition and subtraction are inverse operations. Multiplication and division are inverse operations. And so we now have a new inverse operations we want to share with you. It's called square rooting. So when you take a number and you square it, you get a value of 4. So our new operation, this is going this way. We're going to show you the operation of how to move from the 4 back to the 2. We call this square rooting. The square root of 4 is equal to 2. So this is a new symbol that we'll introduce to you. This symbol, we call it a radical. We call it a radical because, yes, it is radical. It is awesome. Also, it's radical. Like, it's crazy. It's new. It's different. It's a new operation. A radical is this shape. Now, this isn't division, but it's something different. It's taking that number and it's asking it. So when you take the square root of a number, what you're actually doing is you're asking what number times itself, what number squared is equal to the number you're square rooting. So again, that radical is not division. So we're not just trying to figure 4 divided by 2 is 2, but we're actually asking what number times itself is equal to that value. So if we look at all of those perfect squares that we mentioned earlier, so let's kind of make a list. We had 1, 4, 9, 16, 25. We had 36, 64. Oh, I'm sorry, I skipped one. 49, 64, 81, and 100. These were kind of those perfect squares that we referenced earlier. I'm going to do the square root. So remember, the square root, we're going to take the square root of 1. We're asking what number times itself is equal to 1. Well, we know the square root of 1 is 1. I'm going to take the square root of 4. I ask what number times itself equals 4. What number squared is 4? We know that is 2. The square root of 9. What number squared is 9? 3. The square root of 16 is 4. The square root of 25 is 5. The square root of 36 is 6. Square root of 49 is 7. The square root of 64 is 8. The square root of 81 is 9. And the square root of 100 is 10. Because again, what the square root is, the square root of some number is asking the question, what number squared is equal to the number in the square root house, or what I call the square root house, or the radical. So the square root of a number is equal to some number. And really what it means, I guess it's equal to some number. And really what that means is when I take that number and I square it, meaning I raise it to the power of 2, I get the number that I originally started with. So perfect squares and square roots. Square rooting is the inverse to squaring, meaning when you take something and raise it to the power of 2, the inverse operation is known as a square root.